And I just want to ask, I saw that it's recorded. Brianne and Zizi, do you have something to share before we start the conversation? Okay, you're all good?
Mm-hmm.
Okay, great. Okay, so good afternoon, everyone. My name is Ruopeng. I am an associate professor here at the Brown School, and I'm doing research mainly in the field of obesity prevention, dietary behavior, and physical activity. So my work is heavily quantitatively oriented. I'm doing a lot of quantitative modeling, policy simulations, for example, econometrics, applied health sciences, and cost benefit, cost effective analysis, simulation, modeling, and thank you, Zizi, for sharing that. And also, I'm much into the field of artificial intelligence. So today, for this session, I want to talk about just very briefly in a larger picture how we can apply artificial intelligence in terms of machine and deep learning in health and social sciences. So although AI has been widely adopted in many disciplines in industry as well as in academia, but most applications are in natural sciences, in statistics, with the engineering, computer science for sure, and maybe some tend to finance as well. But really, the applications in AI in health and especially social sciences are just emerging. So my personal perspective, many others, we agree that definitely we will see more and more applications of AI in those fields. And it is critical for us to understand what we are expecting for in the near future and also far into the future, and how we can best prepare ourselves as educators and public health practitioners and social workers, how we can be best prepared for the digital age, really dominated by artificial intelligence. So that is the reason why I want to bring this talk to you, and hopefully the talk may inspire you in some ways and maybe generate some interest and discussions about AI. So AI won't have to be a buzzword, but also really something that you can grasp and you can talk about and you can learn in the future. And so Zizi and Brianne are going to monitor the chat. So in terms of the talking, I apologize, I can't monitor the chat at the same time because I'm really not very multifunctional. So multitasking, but then I hopefully will have some time for Q&A in case you have any pressing questions. Feel free to post on the chat or just prepare to unmute yourself by the end of presentation. So we will have a discussion afterwards. Okay, so let's get started. Can you see my presentation slides? Okay, good, great. Okay, so now as we talked, today's title of the talk is Artificial Intelligence Applications in Health and Social Sciences. We are not going to focus on any particular application, but really providing you a larger picture about the landscaping of AI. So first, what is AI, right? In our mind, we have a lot of imaginations about AI. Maybe AI is an almighty know-all, and AI might be the most sophisticated mind. For example, maybe Sherlock Holmes plus Albert Einstein plus William Shakespeare. It has a lot of really highly intelligent, can achieve superhuman performance in all the complicated, sophisticated mathematics or literature or other specific domains. And some of you may think about, well, AI must be a math genius because it seems to be complicated, a lot of math, a lot of statistics. So AI probably would be great in solving those math or statistical problems. So such as this crazy equation, right? For human being, well, it may take years for us to solve, but probably for AI, it's going to be a piece of cake. So no, our real imagination can go wild regarding what is AI, right? And then, well, there are many different definitions for AI, but I particularly like Dr. Koletz, who is really a pioneer in artificial intelligence applications. And his definition in his really landmark textbook talk about AI is the effort to automate intellectual tasks normally performed by humans. So here, interestingly enough, no, AI is not an almighty giant, right? It's not a mathematical genius or something like that, but really AI is trying to do the tasks that we human beings are doing all the time. For us, it's very natural, very easy task, but for AI, actually, it's pretty challenging. It takes scientists years to develop algorithms that finally can achieve possibly near human performance in doing some of the really routine tasks. So let's see what those tasks are. So basically AI are doing, we are trying to use AI to do some really basic cognitive functions. For example, visual spatial ability, right? Trying to giving directions in the geospace, maybe classifying images into different types. So we as human beings acquire those abilities when we were probably baby. Right? Since it's natural to us, but actually it's very hard for machine to learn that. And language comprehension speech, right? So for human being, we all have our mother tongue, right? We may pick up a second or third language, and it's very natural to us. And it's easy for us to communicate via language, of course, not in terms of equations, right? And mathematical symbols. But actually, it turns out to be a pretty hard problem for machine to learn. And maybe ability to learn new information, right? For example, when we were a child, we were taught, well, you have to stay off the fire, be careful not to be burned, right? And if you see a fire, put water on top, but not put oil, right? So we learn this at a really little age. But then how we can truly teach machines to learn those abilities? And a memory, right? We all have our great memories, some best memories, some sorrow memories. But then, but for machine, what kind of memory we are talking about? How can machine acquire some of the memories like human beings? And not to say creativity, imagination, right? You write a novel, you develop a new app, you draw a new picture, and you write a new essay or analytic story. So those creativity and imagination are embedded in the human beings, right? Because we are really very, very creative and very imaginative. But well, in terms of machine learning, how can machine learn those basic cognitive tasks? And so the Merrill-Vax paradox, I think, put this very nicely. The scientists said, years ago, the hard problems are easy and the easy problems are hard, right? So for machine has already been pretty good all the time to solve mathematical equations, giving you approximations based on mathematical statistical properties, right? Looking for patterns embedded in multi-layer of data sets. But really, in terms of the aforementioned cognitive tasks, machines are traditionally not good at them because those seems to be easy problem to human beings, but actually very hard problem for machines. Nowadays we call AI as a general technology, just like electricity, right? Electricity is a general technology. It can be applied to all different industries and sectors, right? It is embedded in your life to the extent that we don't really we take it for granted and we never question, and we only really feel the pain when we lost electricity, right? And AI is like a general electricity, a general technology like electricity. So AI now has been everywhere. It is so broadly used that you hardly think about actually you are interacting with AI on a daily basis, right? I'll give you some examples. For example, how many times in a day, right? Not today in an hour, maybe in terms of minutes that you use the Google or Bing to search something, right? And how many times you watch the YouTube or Netflix, right? For entertainment and for learning opportunities. And how many times you purchase something from those digital domains, for example, Amazon and Shopify, those big vendors, right? And how many times you interact with your friends using Facebook, Twitter, for even younger generation, probably you are using something different, WhatsApp and Instagram and TikTok, right? And probably most of us would have some kind of variables, right? Digital variables, for example, Fitbit, Apple Watch, or something else, right? That may track your physical activity, tell you what to eat, what not to eat, no matter your sleeping pattern, your vital activity signals, and giving you maybe messages in real time. Of course, almost every one of us now have some kind of smartphone, right? Automatic phone system. We probably sometimes won't need to ask others, and we can just maybe ask a chatbot, maybe Google Assistant, maybe Alexa, about the weather, about the news, or something else, right? And also, if you ever use electric banking, online banking system, you know that the banking system have been really revamped using AI technology to, for example, in the fraud detection, in automating banking activities, and so on and so forth, right? So all of those daily activities involve AI. Right? And AI is really the backbone for probably all of those applications that we are interacting with on a daily basis. So that is how widely spread AI is. And we are previously, probably two decades ago, we were really afraid of the so-called digital divide, right? So basically defined as people who know about how to access internet using computer versus those who do not. And we all know, so people who are really exposed to this digital divide and don't know how to access internet are significantly disadvantaged compared to people who know about technology, right? So that was probably the discussion over the last 20 years. But now I would argue, and many probably would agree with me, that now we are really facing the next generation of divide, which is called the AI divide. So basically, those people who know how to interact with AI and how to use AI for information retrieval, for automate tasks, for any of the decision-making processes, they are definitely much more advantaged than the other people who do not know AI, who know that many doors would be shut down because people won't be able to utilize and take advantage of AI for their daily activity, for their decision-making process, and so on and so forth. Okay? So I would say probably in the next 5 to 10 years, we are going to see the AI divide to be more and more significant in the society. And then, I know there's always some confusions about AI, right? Though many times the hand news talk about AI as some kind of evil, taking away people's jobs, and creating biased estimates that make some populations more vulnerable or disadvantaged, right? and usually we call it algorithmic biases. So we talk about, we see a lot of negative consequences of using AI, right? And besides, of course, the major advantage of using AI as well. So here I want to use the analogies of a hammer. So think about AI like a hammer is a tool. Right? There's no evil AI, and nor there is good-hearted AI, right? That is not relevant because AI is just a tool. It's just like a hammer, right? You can use hammer to nail down a nail, and you can use hammer to knock someone's head, right? So you can't really argue, well, this is an evil hammer and that is a good-hearted hammer, right? Doesn't make sense. What makes sense is that we need to consider AI is a tool just like a hammer, but it's a more sophisticated tool. So you can make rules about using hammer. Say you can make regulations to say someone have to use hammer to nail down nail. Anyone who use hammer to knock someone's head would be punished, right? But AI, well, for AI, you can make similar rules, but it's just more complicated, right? Because AI is definitely millions fold more complicated than a hammer. So we're still trying to figure out what AI cannot do, right? So that is to say, if you want to make any regulations for the use of AI, it's going to take a long time. It's going to be a ever-evolving process because we are still exploring the limit of a potential AI applications, right? And well, there's another argument that AI is taking over the world, right? So when I was a kid, I was fascinated. Really, I watched this Terminator series again and again. So many of us nowadays still believe that AI is going to take over the world someday, right? Somehow, just like what was predicted in the Terminator series, right? But really, it is something we need to concern about. Maybe in science fictions, but to me, well, as an AI practitioner, no, I don't have such worry. So previously, there was a famous philosopher, Descartes, who talk about, has a famous saying of "I think, therefore I am." Right. So now, actually, the AI is challenging that convention because AI can think, right? AI can learn, but that doesn't mean that AI knows the existence of itself. So basically, we want to make a counter argument that intelligence is not equal to self-awareness. Okay? So this is a critical distinction because, well, if you consider, if you're afraid of AI taking over the world, it has to have some purpose, right? For example, in the Terminator, the intelligence, how to say, digital intelligence, suddenly know the awareness of the self and then try to benefit its own population by destroying this world, right? But well, the AI, at least nowadays, the AI that we talk about, they are computer algorithms that are trying just to minimizing the human-defined loss function, and that's it. No matter how complicated the model is essentially doing the same, trying to minimize a mathematical function, right? So the AI doesn't have common sense, and AI doesn't have self-awareness. So if a machine has no self-awareness, how the machine would come up with the idea of trying to self-preserve by destroying the human being, right? So at least for now, no, I don't take that argument very seriously. And then another argument is AI is taking away jobs, right? So no, I want to bring analogies from 200 years ago when the Britain was under the Industrial Revolution, right? So if we learn that history, at that time, people for the first time knew how to use machines to create machines, right? The steam engine, the automotive loom were developed so that it take away a lot of labor-intensive jobs, right? So you won't have to use humans in the loom because machine can do a much quicker job, and you don't need animals to push the cart because, well, the steam engine can do a better job, right? But really at that time, when we had the Industrial Revolution, were those machines, would those new technologies taking away jobs? Well, in the most immediate situation, it could. But to be more profound, actually, it didn't take away jobs. It created a lot more jobs than it took away, because it's reallocate the labor market and redistribute the labors from those really hard, heavy, boring jobs to those more creative jobs that do need more human cognition rather than just hard labor, right? And similarly, we see the AI. So if you argue that AI really taking away jobs and replacing people, and then let's take a look of the data, right? In the last 10 years, from 2010, we see a dramatic increase in Amazon to adopt AI, right? So Amazon is probably one of the companies that adopt most of the AI applications over the past 10 years, and then look at the data showing the number of jobs that Amazon was hiring over the last 10 years. It's not decreasing, it's not replacing people, actually is the number of people hired by Amazon increased exponentially over the last 10 years, right? So I would say, no, well, to some extent, maybe the AI is taking away job of a particular kind, but well, I would want really to bring your attention to the Industrial Revolution, so not to overlook the new jobs that are created, are going to created by AI. And then, well, you may ask the question, really, what is the difference between AI and the previous technologies, right? For example, the automation. We talk about automation years ahead of AI, before AI was even invented, right? In the Industrial Revolution, we tried to automate things. But really, what is the difference this time? How is AI more advanced or desirable or advantageous in comparison to those traditionally so-called rule-based algorithms? So the fundamental difference is actually just illustrated here in this simple graph. So on the top part of the graph, we saw the rule-based algorithms, these traditional automation systems. Basically, you need to provide the rules and the data as input, and then based on some classical programming, the machine is going to produce answers. Right? So basically, the machine is going to use the rules that you hand wrote and the data to process the data and then provide you the answer. And in AI, or we call machine learning, modern AI machine learning, we do not need to provide rules. Instead, we provide data and answer. And machine learning is going to learn from the answer data pair to understand how the data are related to the answer, and then it's going to produce the rules. So that is really the fundamental difference. And which one is easier, right? I guess probably all of you could see that the machine learning approach is much, much easier, because handwriting rules can take years. Consider how many rules you want to write to understand human language. You probably spend 200 years and still couldn't figure it out, because it's just too complicated. Because we humans use language so differently. For example, because I'm not a native language speaker, English speaker, so I may have a lot of grammatical mistakes here. But well, if you write all this in the rules, well, it just takes forever, right? But machine doesn't need that. Machine learning can adapt the data, and then by learning from the examples, the machines will come up with the rules that are very complicated, but practically very useful. To nail this idea down, let's compare how a traditional rule-based algorithm and AI are going to handle a very simple task of filtering out spam emails. right? So nowadays, all of us have Outlook that have some type of filters, right? Mostly, actually, most of them are AI-based filters to automatically fill out spam emails. So for the rule-based system, in order to differentiate between the spam email versus real email, you as a programmer has to write all the rules. Maybe one rule is any email containing lottery, the name of lottery, or containing 3 asterisk, or containing winning, those words should be considered as spam email, right? But well, things change, right? Maybe it works in the first year, and second year there's new trending, right? There's new phishing email that use different wording, and you have to change your rules, right? And the rule can be arbitrarily complicated and also contradicting each other, right? But in machine learning, you don't need to do any of that. You just provide the machine with a number of emails that are spam emails and a number of emails that are real emails, and you label them. You tell machine which one is a spam email, which one is not. And the machine is going to come up with, by training the machine learning program, it's going to be able to learn from the data examples, and then come up with the model that can differentiate spam emails from the real emails. Okay. So that is the fundamental difference between machine learning and rule-based modeling. And so, in terms of the scope of artificial intelligence, you would consider artificial intelligence is an all-encompassing, big idea concept, and it contains machine learning. And so machine learning is a subset of artificial intelligence, or we call it modern artificial intelligence. Okay? And deep learning is a subset of machine learning. So the deep learning basically uses multi-layered neural networks. We call it layers. So basically a layer is just a set of neurons, of course, artificial neurons, not the neurons in our brain, to learn complicated, abstract, and highly nonlinear relationship and patterns. Right? So when we talk about AI, modern AI, we are really just talking about machine learning and deep learning. And here are the differences between machine and deep learning. So the machine learning, often we call it shallow learning, and the most used in tabular data. Tabular data means that you have a number of rows and a number of columns, right? It's the most common data set you've seen. For example, if you use say digital, maybe you use a health survey or digital medical records. So you must be familiar with those tabular data. And machine learning is probably best suited for those type of data. And why it is shallow learning? Because it has only one layer, basically a single layer of weights that are learnable to build a model upon. And the deep learning as the counterpart of machine learning, so the deep really come from many layers of artificial neural network. So that is where the term deep comes from. And here, so the deep learning are really best suited for learning more complicated and untraditional so-called big data. For example, images, videos, audios, text, speech, right? So those data are often unstructured or semi-structured, and those data usually represent a more complicated relationship that can be hard for a shallow learning algorithm to learn. So therefore, we often have a demand to use deep learning. And here this figure shows the deep learning. So basically we have an input, right? Maybe the input would be a batch of images, some videos or audios or natural languages, paragraphs or articles. So you consider those as the input to the input layer. L1, and then you will see that the purple dots denote the hidden layer. We can have really arbitrary number of hidden layers, and the more hidden layers you have, the more complicated model is going to be, and the more difficult and complex relationship this model are going to present. Right? And then you will see that those input layers are densely correlated with those hidden layers, right? And then, well, then the final output on the right-hand side are represented by the red dots denoting the output layer, right? So basically, it's going to, in a nutshell, deep learning is just trying to match the inputs to some kind of outputs. Maybe the inputs are images and outputs are labels, for example, whether an image is a cat or a dog, or maybe the inputs are Wikipedia files, and the outputs would be some classification of the topic, or maybe creating like a new paragraph, about something. But so basically, the deep learning is just a match between the inputs and outputs, but the middle can be arbitrarily complicated, right? Using more layers, using more nuances in the layers, so that the model can really incorporate arbitrarily complicated relationship. And in terms of different type of AI systems, we usually can classify them into 3 types: unsupervised learning, so learning by data only. So basically, for example, we only provide dog and cat images, but we do not label them. So the machine are not going to tell whether an image is a dog or cat, and the machine is going to learn some, for example, clustering patterns, try to cluster maybe dogs together and cats together. So that is called unsupervised learning, learning by data only. And supervised learning is really learning by examples. Examples means we provide both data as well as labels to the machine, so the machine may, for example, classify them, right? So we provide not only the dog and the cat image, but also there's corresponding labels. So we tell which image is a dog, which image is a cat, and the machine is going to learn the relationship between the image and the label and try to come up with the rule. And finally, we also have the reinforcement learning, so learning by incentives. So for example, how you can really tell a machine to put out a fire, when it sees it, and then but not directly approaching fire to get burned, right? How can you teach a machine to do that? Well, the baby can do that. And how baby learn that? Because, well, every time if the baby is approaching fire, the baby get punished. And if the baby every time, say maybe grab some water to put out the fire, you give the baby maybe some milk, right? And we do the same for machines. When machine is doing this, when a machine automated agent is trying to approach the fire directly, we give a negative incentive. Basically, we reduce maybe 10 points for the machine. And when the machine is doing the right way, trying to put out the fire with water, we give the machine positive incentive, maybe 100 point of incentive. And the goal of the machine is just to maximize the incentive, right? And that's enough for machine to learn over time how it should respond when it sees a fire. And AI models, well, we are seeing really the landscaping is changing dramatically. We consider we are building really more and more powerful models with more and more parameters, right? If you learn about regression analysis, probably you'll be building a large model, means you have maybe 50, 100 features, right? Weights, right? But in machine learning, well, for example, the language models in the early days is like 10 years ago. So the Google built the language models that have 12 million parameters, right? Is Albert, they all use this very funny name of Sesame Street characters to name those language models. So there's bird and big bird and Robert and all that, right? And you see that over time, we are building larger and larger models. For example, the state-of-the-art language model built by OpenAI, GPT-3, now has a daunting number of 175 billion parameters, right? That is how large the model is. It's almost approaching the number of neurons in our brain, right? So of course, those models would have superhuman, a lot of near human, or sometimes even superhuman performances in understanding natural languages. And well, if we talk about AI, the application of AI in health and social sciences, it is really a really emerging domain, but many applications. Of course, this list is just a tip of the iceberg, right? For example, it has been applied to CT scan and imaging, try to identify tumors, right, from affected organs, from the CT scan or MRI images. AI has been applied to extensively to patient healthcare. So recently, some of you, if you were in Washu before and listened to a presentation, there was a German-based companies that built an AI automated machine that can transfer patients from different from different places carry patients into different places in the hospital, right? And AI has been used to predict the disease onset, for example, diabetes, cardiovascular disease, stroke, fall, right? And AI has been widely used in sentiment and trend analysis using social media data, right? Because we are producing definitely more data than we can ever analyze, right? Consider the number of tweets, the number of social posting in Facebook and other social media. And the AI has been used to track the trend and try to create on-time, real-time monitoring of the sentiment, for example, people's emotion about COVID-19 pandemic, right? And AI has been used in theme and topic identification and synthesization. For example, there were applications using topic modeling to look at 100 years of New York Times publications, right? Consider the sheer volume and that human we would easily spend a few thousand years to analyze the 100 years of New York Times publications. And not to say to classify them and to summarize them, right? But machine learning can do that. Well, there's a really increasing demand of both companion and therapeutic chatbots. So I don't know whether many of you have used that. It has been really on the rise. So we nowadays, the therapeutic chatbot can, to some extent, help people diagnose and treat mental illnesses. Many, especially young generation, are increasingly interacting with companion chatbots, the replica and many others on a daily basis, right? Asking them questions, maybe just for general chatting. So there were a lot of common misperceptions about AI, right? Because AI to many people is just a buzzword, to others is really something evil or something need to be cautioned of. So and to learners, right? And for example, especially for our graduate students. And we hear about many applications of AI, but there are still a lot of misperceptions that prevent people from becoming a person interested in AI to a person that's learning and applying AI, right? And believe it or not, the real hurdle that I've seen is not the lack of skill set or the lack of talent or the lack of motivation to learn AI. On the contrary, it's really a lot of those misperceptions about AI that prevent people from learning more, from actively engage in and serious consider in learning AI and acquiring those technologies. And here I summarized a few major misperceptions that prevent people from engaging in AI learning. One common misperception is AI is too much math and statistics, right? I'm a social scientist. No, I don't want to mess up with math, right? It's not my food. Is not my taste. And I really don't want to look at those mathematical equations, right? And the second misperception is too much programming, right? No, again, I'm a social scientist. I'm working with people, not working with computer. So that computer scientist mess up with programming, and I don't want to touch coding. Right. Another misperception is, well, AI is just need too much data, right? No, where, no, as I'm a social scientist, where should I, how can I collect so much data to feed into the AI algorithm, right? So you already know AI, probably need maybe 10 million observations. How could I get those 10 million observations, right? So therefore, AI is distant to me. No, I have no resource and I have no application for AI. Another misperception is AI is expensive, right? AI often requires a GPU-powered computer, which is out of my budget. No, I just do not have the computation resources to do any of those complicated modeling, right? And another misperception is, no, even if I learn AI, even if I become a practitioner, I still cannot compete with professional AI scientists on the job market, no matter how much I learn, right? Because they are professional. I'm just nobody. So why should I learn something and then still feel not being competitive enough on the job market, right? So those are the misperceptions that I've often seen. So let's talk them one by one. The first one, too much math and statistics. The short answer is yes. The AI definitely involve a lot of math and statistics and engineering. But really, for most AI practitioners, you don't need to know the math and statistics behind the algorithm. Okay? You won't have to become a mathematician or statistician to become a good AI practitioner, right? I would say 99% of AI practitioners do not really learn the mathematical equations and try to derive the formula or approve the algorithms, because it's not needed. It's not your job. It's not your concern. You are really on the application side. It's just like you learn regression. You won't have to prove every single algorithm, like central theorem, to be able to apply regression, right? And then so for AI practitioners, the intuitions and experiences are definitely tenfold more important than the math behind. For example, it's vitally important for understand the bias variance trade-off in machine learning. But that is not to say you have to mathematically prove that the total model variance equals bias plus variance plus irreducible error term, right? So modern AI is more engineering than math proofs, because actually, for most of the AI algorithms, they are developed not actually from the statistical theorem or mathematical theorem, but it really come from the trial and error, right? It's much like engineering. You try this works, and really you don't know why this works, but it works, and that's the most important. And then second, too much programming, right? So AI programming has been become increasingly simpler thanks to Python, which is a high-level programming language, and high-level APIs. There are many high-level APIs that really make your programming much easier. And nowadays, probably you've heard of no-code programming, right? There's a language model based on GPT-3 that allow you to do to create softwares or apps without understanding anything about programming, because you just need to describe what you want to do, and the machine learning models are going to come up with the code to do the work you ask it to do. Right? Amazing, right? But well, in general, we are not at the stage yet, but we see the trend. We need less and less programming because of the high-level APIs. For example, here, you see there's the first two lines of code, right? The random forest regressor and RF-FIT, right? Those two lines of code is going to run a state-of-the-art random forest regression for you. Okay, easy enough, right? And no, you will see that the second few lines of code, right? But actually they are just 3 lines because I put them into different lines to make it look easier. But it's just 3 lines. The first line is creating a sequential model. And the second is compare the model. And the third is fit model. That is all you need to create a neural network model, right? A deep learning model. 3 lines of code, right? No, is this difficult? Well, of course, there's a learning curve, but I will say no to most of us, no, even social scientists, no, the barrier is not probably as large as you imagine. And no, another argument is need too much data become useful, right? So this is where the transfer learning can help. So transfer learning is really nowadays the standard application of AI because it allows you to stand on the shoulders of giants. Because there are so many models that have already been developed. For example, computer vision models based on 14 million images classified into a few hundred categories. And the language models that were built based on the whole Wikipedia text, right? Think about how many, what the space of the model occupy, right? So it means that, well, if you build a new model, you are not going to start from scratch. 99% of the time, you are not start from scratch, but you build upon those giant, mighty model with billions of parameters, right? And just you need to tweak a little bit to achieve state-of-the-art performance using a much, much smaller sample size, maybe tens, maybe in the hundreds, mostly a few thousand, right? So here I show you an example, a GPT-2 model prediction, right? So I wrote the first part of the sentence, and I do not do any training. So here I do not provide even a single example for the machine to learn. I just use the model to do a prediction, right? And see how good the model already is. I wrote, life is like a box of chocolates, right? The very famous saying from Hank's movie, right? Forrest Gump movie. And look at the second part. So the blue part was actually predicted by the GPT-2 model. It opens into itself. It fills it with life, and it's all about sharing. Wow, this is amazing, right? I can't really write something like that. It's very artistic, right? So if I tell you this was written by a machine, would you believe it? And if I tell you the machine is not even trained on the data, on new data, it's just to make a so-called zero-shot learning, basically no data provided at all. Would you believe that? Right? And then some may concern about computation resources too expensive, right? But good news, you don't need to purchase a GPU-powered computer. I don't have a GPU-powered computer. You can use a lot of free resources. For example, Google Lab, link provided, and Kaggle, link provided, often offer free GPU computing to some extent. I think if you want to use more GPU, yes, you can also purchase them, but very affordable rate. A few bucks a year, up to, of course, if you want to do really state-of-the-art modeling, you probably need to pay more. But bottom line is you can use whatever junk computer you have. Right? Look at the photos here. You can use your iPad. You can use a 10-year-old computer. It doesn't matter as long as the computer can access the internet. Then you can access the cloud computing resources, and then you can use them. And with a very low rate, right? So therefore, nowadays, I don't even need my personal computer. My computer are not advanced at all. And I can use any computer. I can use my iPad to do the computation as long as I can access the cloud computing platform. And well, another obstacle, another misperception is you can't compete with professional AI scientists. Yes, you can't, right? Because they are professional, they are trained to do AI modeling, but you may never need to. You may never need to, because the job market really value people with interdisciplinary background. For example, if you're a public health practitioner, if you're a social worker, but you are also a data scientist, those are the most rewarding combination in the job market. And you are not competing with statisticians. You are not competing with AI engineer, right? So you are competing still in your own domain. You are competing with other public health practitioners, competing with other social workers, and you are probably the public health practitioner, social worker that know the most about data science, and that is your competitive advantage, right? So, have you ever seen a AI expert competing for a public health job? I have never seen that, right? Nor you are going to apply for an engineering job, right? So no, we are still in our own domain of expertise, but we just bring additional edge, borrowing from data science to our own domain, right? To make us us more competitive on the job market. And then, well, if you want to ask me, if I hopefully convinced you enough, you can and you should learn AI. And where do you start, right? So I have 2 courses offered, 3 courses actually offered at WashU. One is applied machine learning using health data. I offer it every spring. And applied deep learning using health data, we offer every fall, starting from next semester. I'm going to offer this for the first time. And also we have a postmaster certificate program, right? So if you already acquired your master's degree and you want to learn more about AI and get a WashU certificate, and then you are more than welcome to participate in this artificial intelligence applications for health data. It is a postmaster certificate program offered starting from this fall. And I provide the link here in case you are interested in register. So we are going to really mess up with the AI programs and try to test many models and applications on health and social science data. And well, we are later on in fall 2023, we are going to roll out our AI certificate program. So this certificate program is different from postmaster degree program. The postmaster program is only a 3 credit, a full course, but the AI certificate program for our master and PhD students consists of 2 courses and also 2 skill labs. So we are going to roll this out in fall 2020. Actually in fall 2023. If you are interested in doing that. And so I also provided a few resources to learn. For example, scikit-learn is a great Python library for doing machine learning. NumPy is great for data manipulation together with pandas. And then matplotlib is great for data visualization. And JupyterNet Notebook and Google Colab are great if you want to really learn about apply Python programming. Those are the excellent platform for you to write the programs. And there are 2 recommended textbooks, one on machine learning and one on deep learning. I know there are hundreds of different textbooks and most of them are junk. So those 2 textbooks are really the best of its kind. So I would highly recommend. Okay, so that's all I want to talk about. And I'm open to questions. Any questions and comments, feel free to raise them. So feel free to either post your questions on the chat or just unmute yourself and ask a question. And I saw that Zizi posted the AI postmaster certificate program. Yes, definitely take a look if you're interested in that. So no, the certificate program is developed for those who are interested in AI but have never applied AI nor have any programming skills. So really, we are going to start from the basic Python programming, moving all the way to complicated deep learning models. Any question, comments?
Well, I just had a comment. Very, very interesting. Thank you so much for the talk. And I learned a lot. So this certificate, do you have to have finished the master's to get it?
So for majority of the working professionals, I think the answer is yes, but there could be some exceptions. So basically, for example, if you are approaching the end of your master program, but still not get the completed, you can ask for an exception. So we have the contact there in the branch in the contact. The branch will contact, and you can consult with them. I think they have some procedures to make that happen. If you are approaching the end of your master's program.
Okay.
Great question. Any other questions, comments? Brianna, Zizi, you have any comments or anything you want to share with our really brilliant audience?
I have a question. So I heard that like WashU has been, really encouraged like interdisciplinary learning and also encourage students to take courses not just in the Brown School. So do you also teach this course at other schools under WashU? Is there any opportunity to learn it with students, maybe their major is engineering or computer science or anything?
Right, this is a great question. So we do see quite actually for this this semester, I'm teaching the machine learning course, and I do see a few students from medical school coming to take my course, and actually probably 2 students from other universities as well. So based on the university arrangement, they can take my course. But really, the course is mainly for health and social scientists. Really not for engineering students, because for engineering students, they probably learn this from a different domain, right? They need to learn about the algorithm itself, because their role is not to primarily use the application, but to develop new algorithms, right? So the angle will be quite different. But really for health and social sciences in general, for example, students in political science, maybe in nutritional science, in social work, public health, medicine, and so anthropology. So we do see a interest in that. But we actually my course, the applied machine learning, is really capped. So we increased the cap 2 times. First, we only admitted 15 students, but the course was filled within the first hour, and then we increased that to 25 and filled within 2 hours, and finally we increased to 30, but we just can't increase the capacity anymore because we can only accommodate so many students. So we do see a huge demand from over the campus on those new courses, especially how our angle of doing applied machine learning. We are not really learning mathematics. We are not really to do any proof, but we are trying to know how I can learn about enough programming and enough modeling so that I can apply those AI technologies to the real world questions I care about and interested in. Okay, so any other questions? We have 1 minute before we hit the clock. Any final thoughts and questions? Okay, you are most welcome. Okay, so if we not further questions, we'll hop off. And really nice meeting you all. And I wish to see many of you in my courses. And if not, definitely on WashU campus, which is we have beautiful spring here. And after the pandemic, we really want to see all of you, not only virtually but also physically. Okay, so thank you so much, and especially thanks to Zizi and Brianna for hosting this, and thank you our audience for your patience and your interest, and I wish all of you a great rest of the week. Bye, everyone.